every day you would remember. Otherwise, I would have. I always get to forget that. Thank you so much. So there you go. I hope you're able to see my screen. So let's have a quick recap as to what we have discussed yesterday. Okay. So there you go. Anything that you could remember from yesterday, guys? Either you can speak or you can put that on the chat box. So we have Shraddha saying that we started discussing about servers. The wonderful. So we have discussed what is a server. What is a server? Okay. So today also I'm still waiting for a moment because I may call you. Okay. So anything else, guys? So what is a server? Then we have spoken about the different layers. Okay. So what are the different layers that we have spoken about? The application layers. What are the different layers? Wonderful. The presentation layer. What is the second one? Business layer. Wonderful. Business logic layer is what they say. Let's say BLL. Business logic layer. And the third one is the DML. Okay, which is the database layer. So wonderful. So we have understood these three layers very clearly yesterday, and we also understood what is a server. What is a server, guys? A software which can I'm waiting to hear from you. Okay, wonderful. It understands your request. Software which can understand your request. So what is the second thing that it will do? What is the second thing it will do? Respond to your request is the last one. Okay, so once it understands the request, okay, wonderful, Majid. It's a combination of hardware and software. Okay, so let me call this as a software plus hardware as well. Okay, because the software itself will not work. Okay, so it will understands the request, process the request. Okay, because it needs to get the work done. First it needs to understand, then it needs to get the work done, and then finally it can respond to the request. Okay, so a software is a combination of a software and hardware which first understands your request, then it processes the request and sends the response back. Anything which has the capability to do that, or any software which has the capability to do that, then you can call that software as a server. But the software itself is of no use, so you have to have a hardware. You have to have a hardware. Yes, Shraddha, we have discussed about different kinds of servers: the file server, the database server, the app server, the print servers. Like this, we have whole lot of servers. So we have discussed about all that. Okay. Then we moved on to the layers. Okay, so with the help of the layers, the presentation layer, the business logic layer, and the database layer, we started discussing about the architectures. So what is the first architecture we have discussed? The very first one. Wonderful. It's a two-tier architecture. Okay, it's a two-tier architecture, or we can also call this as, or we can also call it as a two-tier architecture or a client server architecture. Wonderful. Okay, so it's a two-tier architecture or a client server architecture. Okay, so it's a two-tier architecture or a client server architecture. This is what we can say. So there are two kinds of two-tier architectures. What are those? Wonderful, wonderful. Okay, it's a thin client, and the second one is obviously a thick client, okay, or a fat client. As I've told you, this is one of the favorite interview questions, irrespective of the field, whether you're going as a manual tester or whatever the tester, people like to ask this question. Not many, but certain people. Okay, so that's what it is. So this is how far we have discussed yesterday. Okay, now we will jump into the next important topic, which is the three-tier architecture. Okay. So just to give you a background, guys, the layer in which you can give an input or it will display the output, you can call that layer as a presentation layer. The layer in which the actual processing happens, the processing of your request happens, you can call this as a business logic layer. And the last one is where the data is stored, and if required, we should be able to retrieve the data. So that is the data tag. Okay, so in this case, what you said as a user is, I want the present. Yeah, we are recording the session, Dinakar. Thank you. So I hope we are recording. Let me check. Yes. Okay. So from this layer, a user has said, I wanted to get the transaction history. So from the business logic layer, there is a piece of code, which is smart enough, and it has created the query and fired the query on your database. Okay. So from this data tier, we have the capability to retrieve the data as well. So that's what we have done. We have retrieved the data, which is transaction 1, transaction 2, transaction 3. Okay. So now again, your logic layer will put all these transactions, put together, and then finally it will display on it. You see, this seems to be transaction 1, this seems to be transaction 2, and this seems to be transaction 3. So this is the presentation layer. This is the business logic layer. And this is what is the data tag. So based on these three layers, we'll be discussing the architecture now. Okay. So we started discussing, okay, the client server, the presentation layer is on the client, the business logic layer and the DML is on the server. Okay. This is what is a thin client. We have discussed this. We have spent quite some time yesterday on this, guys. We have spent quite some time yesterday on this. Okay. But here, so this is the thin client. When we're talking about the thick client, the presentation and the business logic layer is on the client and the database layer is there on the server. So we have discussed that anything that you have to install and use it, so that's what is a thick client. Okay, so some of them came out with the Skype or the GoToMeeting with which you are attending. You do have to download certain. You can connect two ways. One is using the browser without downloading anything, then that becomes a thin client. But one is after downloading. So that will become the thick client. Okay. So I hope, Shraddha, all your issues with the connections are gone. Yesterday we have spent the time. Okay. Now, then the people started thinking, however we could have, we have this capability of having the machines talking to each other. And here, if you look at this thin client, you're burdening this server side with the additional task. You see, the business logic layer is the additional task. Okay, so we are burdening this server with this. Or if you're going with the thick client, you're burdening that business logic layer on the client. So either ways, you either is burdening the server or burdening the client with the additional task or the additional work. Then they also thought that however we have this capability to have this users talk, you have these machines talk to each other. Okay, you have the machines talk to each other. So then they said, why not we give a different machine to business logic layer? Why it should either have to be put on the server or put on the client? So they said, okay, let me give a completely different machine to the business logic layer. Okay. So then they came out with the three-tier architecture. You see, on one machine, you have the business logic layer. On one machine, you have the business logic layer. On one machine, you have the database management layer, and on one machine from which the person sends the request, that's the client. Again, I'm telling you, the client need not have to be a desktop. It could be a laptop, it could be a mobile phone, it could be your tab, it could be any machine from which you can send the request to the server. Okay, it could be any machine from which you could be able to send the request to the server. Okay, so in the three-tier architecture, the only difference is they have given a separate machine to the business logic layer. They said, you know, why we should burden this business logic layer either on the server side or on the client side. So let me give a completely different machine to it. So this is how a three-tier architecture came into picture. A three-tier architecture came into picture. So they have put the business logic layer on one machine. They have put the business logic layer, the database management layer on one machine, and the presentation layer is on the client. The presentation layer is on the client. Okay. So this one, the business logic layer, where the machine on which the business logic layer is put or installed, we can call that as an app server. We can call that as an app server. Here carefully guys, you know, this is where the business logic is happening. This is where you're putting that code which your developer has developed. Okay, this is where you're putting the code which your developer has developed. Okay, so we are calling this as a where your business logic layer is, we are calling this as a app server. What is the full form of app server, guys? We have discussed yesterday. I want to hear from you. What is an app server? What is the full form? Application server. Yes, application server. Okay, so the application server is where you put your code. Okay, so developer will create or develop some piece of code. Okay, develop some piece of code. He's developing the piece of code for what? For different functionalities. For login functionality. Okay, if you are assuming that this is an Amazon, okay, add to cart functionality. He's developing the piece of code for all this. Okay, so login functionality, add to cart functionality, logout functionality, check transaction history functionality. So some piece of code needs to be developed for all these functionalities and even more. Whatever you see, check to card, you know, return, delete, whatever the functionality that is available on the application, there is definitely a piece of code that needs to be developed by the developer. Okay, and that piece of code needs to go on this app server so that as a user, you can use these functionalities. Not only this, there are whole lot of functionalities which are there on Amazon, and for every single functionality, the developer has to create the code for that, and that is all being put into this app server. Okay, will be put into this app server. Okay, so which programming language will be used? It could be used by any programming languages. You can use a C programming language or a C++, okay, or a .NET. Okay, very most likely it will be Java, because Java is the most popularly used. Okay, Python or any of the programming languages. Okay, they can use any of the programming languages and create the business logic for all this. Okay, the idea is to create the business logic for the login functionality, add to cart, logout, check a transaction history and all that. But which programming language, it totally depends. Okay, it could be done in C, it could be done in C++, .NET, Java, Python, or any of the programming languages. Okay, the architect will usually select this based on your application, based on what is the best suitability for your application. A program can be developed. Okay, that kind of program is put on the app server. Okay. Now what happens typically? A request from the client server, from the client, will be sent to the app server. From there it goes to the database server, and required, if there is a data requirement, then it will go to the database server. Database server will send the response back, and the app server will do all the all the massaging and all that, and finally sends the response back to the presentation layer. So this is what is the 3-tier. So the beauty about this is they are not burdening the business logic layer either on the client side or the server side. And no wonder we are calling this as a 3-tier, because you have 3 tiers. This is the first tier, okay? This is the first one, and this is the second one, and this is the third one, okay? So you see advantages. Separate processor might be present for each layer. Processor has been the machine. Once we are talking about a machine, how a machine would have definitely a processor, a RAM, and not a RAM, a memory, a processor, a memory, and the hard disk. What does each machine contain? Yesterday we have discussed, guys. Any machine, whether it's your mobile phone or the disk. Sorry if I haven't said that. So any machine would have a processor, okay? So a processor, memory, popularly people call this as RAM, okay, and disk. Some people would like to call this as hard disk. Okay, so in a layman's language, that's what it is called. So any machine has the capability, has these 3 basic components. Okay, so whether we are talking about a server machine, whether we are talking about a desktop or a laptop or a mobile phone, these are the basic 3 components. Okay, so we are giving each different processor for each different layer. If you're giving a machine, definitely we are giving a processor as well. Okay, so you see, separate processor, separate machine means separate processor certainly. Okay, separate processor might be present, not might be present, will be present for each application layer. Okay, so the architecture is simpler and can be scaled easily. Scaled as in if you wanted to increase, you can increase. I'll talk about the scaling up shortly. Okay, so I'll be talking about the scaling up shortly. Okay. Now we'll discuss about the entire architecture. We'll discuss about the entire. We discussed about the 2-tier, 3-tier. Now we are discussing about the entire architecture. Watch here carefully, guys. So when we are talking about the entire architecture, here we have a client and you have an app server where the business logic layer is, and we have the database server where your database management layer. Okay, and finally you have a web server as well. Typically, if you're dealing with the web applications, you have to have a web server. Okay, so now let's see what happens in this entire architecture very clearly. Okay, now the first question is, why are we not calling this as a 4-tier architecture? I'll definitely come and answer that. I'll definitely answer that question. Okay, I'll definitely come to that point and definitely answer that question. Okay, so but we'll first try to understand what is happening over here. Okay, what is happening over here? There are 4 tiers: client, web server, app server, database server. Your business logic layer is there on the app server and your database layer is there on the database server. Okay, now and since you have a web server, okay, you can start accessing the web application. Since you have the web server, you can start accessing the web applications from your client. Okay, so let's say the web application that you are trying to access is your facebook.com. Okay, so you go to your client, open the browser and you say www.facebook.com. Okay, you enter. As soon as you enter, where does the request first go to? The request goes to the web server. From the web server, the request is sent to the app server. Okay, so now the app server says, oh, you wanted the page of the Facebook. Okay, let me process it. Okay, so since this is a server, it has the capability to process the request as well, understands the request, process the request as well. So it will process the request, sends it back to the web server. Web server will do the necessary things. If it has to add any images and then the formatting and all that, it will do that. Okay, and finally will send the response back to the client, and this is when you are able to see the launch page of Facebook. Now as a user, what would you do? You put a username. Okay, you put a username over there and you put a password over there and click on the login request. Now when you put the username, no request is sent to the web server. when you input your password over there, you're not sending the request. But once you click on the login button, now a new request is sent to the web server. The web server will send it to the app server. Now app server has to make a decision. The app server has to make some has to make a call. So what is that? Okay, let's see what is the logic which is there on the app server, which is given by the developer. Let's see what is there. App server contains the business logic layer, right? So let's see what is the logic which is there for the login on this app server. What is the logic which is there on the app server? If the username and password is correct, then build the next page. Else, print out the error message saying that your username and password is incorrect. Okay, so this is the logic that is there on the app server. App server contains the business logic, right? The business over here is the Facebook, and it contains the logic. Let's see what is the logic which is there for the login functionality. What is the logic is there? If the username password is correct, then build the next page and give it to the web server, which will give it to the client. Else, create this page printing out the error message saying that either your username and password is incorrect, or whatever it is, your username password is incorrect. Whatever the error message which is appropriate, it will create that error message, send it to the web server. Web server will create the page for that and send it to the client. So this is the logic. Now, whatever the username that you have entered and the password that you have entered from the front end, that username and password is there with the app server. But it has to check if that username password is correct or not. Where is the actual real username? Where is your username and password, which is the correct username or the valid username is? Where is it present, guys? This is what you have entered now. But where is that actual username and password is present? Where is it present? Your real username and password, with which it can validate. It is present in the database. How it can present in the database? Because when you register, the very first time when you have registered with the Facebook, you said, I want this username and I want that password. I want this username and I want this password. That will be stored in the database. Now, next time around when you are trying to log in, what it will do? It has already stored that username and password in the database. Okay, it's already present. Now you have entered the username and password to log in. Now the business logic layer is saying that if it is correct, then do something else. Do something. The correct username is there in the database. Now what will the business logic layer or the app server will do? It will fire the query on the database. Okay, it will fire the query on the database requesting for the actual username and password. So the database will send the actual username and password. Now the app server will will compare the username that you have sent. Okay, so it has both the sets now. Okay, the username and password that you have sent, that set, and it has received something from the database, that set. So it will compare both of them. If they are good, if they are correct, then it will send the next page, which is the wall page. If they are not good, then it will send out the message. It will send out a page with the message, either your username and password is incorrect. Okay, so let's assume, just for our discussion purposes, the username and password is correct. Then it will build your the wall page. Okay, and it will send it to the web server. Web server contains all the information of the pages, the layouts, and all that. So whatever the information it is received from the app server will put on that layout, and finally will send to that client. And this is when you will be able to see the next page. Which is the wall page. Okay, I've been receiving some questions here, but I will take that. Let me come to the logical ending of the topic and I will take all the questions. Okay, but keep putting your questions, that whatever you are facing. Okay, now you see, the very first time, it just have to go to the app server, web server, and the client. The second time it has to go to the database server as well. And as a client, you won't keep quiet. You will send one more request, then the same story happens. So every time you're sending the request, the same story happens. The combination of web server, app server, if necessary database server with the connections will serve your request, guys. It's not one server which is serving your request. It's a combination of all the servers which will serve your request. Sometimes the database server is involved, sometimes it is not involved. Okay, so this is the story. So this is what happens in the entire architecture. You see, every request that you send, so much happens behind the scenes that you don't even know. So much happens behind the scenes that you don't even know. Okay. Now, the next one is, what is a transaction? Okay. So there are two things. Now I will introduce a term called transaction. Okay. What is the transaction response times? Okay. I'll introduce these two terms now. Watch carefully, hear carefully. It is very, very important. Okay. Without a performance tester, there is no performance tester who doesn't know these two terms. Okay. So you have to understand these two terms internally, not just externally, the internally. Okay. So Shraddha, any application that you're seeing is an entire application, typically the Facebook, LinkedIn. We can't get into the architecture of it, but they're all entire architectures. Okay. These are all entire architectures. Whatever you are seeing, in general. Okay. They're all entire architectures with more complications, honestly speaking. Okay. So whatever you're using, Gmail and all that, we can't get into those architectures. They won't expose the architectures. Most likely it will be an entire architecture. Okay. So most likely if there is a web application, the chances of it being an entire architecture is really heavy. Okay. Now watch carefully. So far it is clear, guys. I have some questions coming in, but I'll take those questions when it's appropriate. But others, is it clear? Is it clear, everybody? Shraddha, I know you have asked two questions. Okay. I'll talk about the web server separately now. After this whole chapter is done, okay, I'll talk about the web server. That is when I'll be able to explain, the couple of questions that you have asked, Shraddha. Okay. Wonderful, guys. Wonderful. Okay. So it's going nice. So what is the transaction? Okay. So you see, so let me clear this picture. So from the client, you said www.facebook.com. It went to the web server, app server, and the app server. It went to the app server, web server, and finally you're able to see this page. So in performance testing language, this is one transaction. In performance testing language, this is one transaction. The transaction is happening between whom? The transaction is happening between the client and between the servers. Okay. If you go to the grocery store, the transaction is happening between whom? Between you as a customer and the owner of the grocery store. Okay. So the transaction is happening between you and the owner of the grocery store. Okay. You go to the shopping center and you purchase the clothes. Okay. The transaction is happening between whom? You and the person, the shop owner, the cloth store owner. Okay. So whatever we do in the life, it's a transaction, guys. Okay. Anything which is related to the business, that's a transaction. Okay. The transaction happens usually between two different people. But here also there is a certain transaction that is happening. The transaction is happening between the client and the server. Okay. The client and the server. Every time you are sending the request, the server is serving that request and giving the response back to you. So there is a transaction that is happening. So it is a client. You asked for a launch page, then the server said, oh, I'll build the launch page and give it to you. So it has given it to you, and now the transaction is complete. Okay, so the transaction between you and the servers. Now again, from the client, you're sending one more request for the login. Again, there is a transaction that is happening between you and the server. Okay, so this is a new transaction. So you can name a transaction. So the very first time you're requesting for the launch page, your launch page of the Facebook, you can call this as a launch transaction. Okay. The second time around, you're sending the request for the login. Okay. If you wanted, you can call this as a login transaction. Okay. Like this, next time around, you will send one more transaction. So you can call that as some other transaction. And finally, you will send a request for the logout. The server will log you out. Then you can call that as a logout transaction. So every time you think a request is being sent to the server and the server is sending the response back, that's a transaction, guys. That's a transaction in performance testing language. Okay. Now that I have told you what is a transaction, I will be going and using this transaction almost in every single class. So I'll be using it very vastly. Okay, so in the class continuously you get to hear from me this word called transaction all the time. Okay, so I hope the transaction is clear to you. What is a transaction? Now, okay, let's go back to the first transaction. Let's go back to the first transaction wherein from the client you said you wanted a facebook.com, you said www.facebook.com, and the request is sent to the web server. Okay, so it is put on the network and it is sent to the web server. Okay, so so let's say you are accessing this from New York. Okay, and all these servers, by the way, we call this as a data center, guys. What do we call this as a data center? DC means data center. Okay, DC means data center. All these servers are there in your data center, and let's say the data center is there in Mumbai. If you don't know where is Mumbai, Mumbai is in India, guys. Okay, so let's say the data center is in Mumbai. Okay, let's say all the servers are there in the same data center and it is in Mumbai. Now this is in New York. This is in New York. You are accessing the website from New York. Now the request is put on the net and on the network, and the request is sent from New York to Mumbai. Okay, so it will reach the web server. It will reach the web server. The web server will process the request. It will take certain amount of time for the web server to process the request. Will be sent to the app server. The app server will take certain time to process the request. Will send the response back to the web server, and finally the web server will put all the information together and it will send the response to the client. And this is when you are able to see. So if the response is put on the net and again will be sent from Mumbai to New York, and then you'll be able to see it. So you see, it will certainly take some time to for the request to travel. Okay, this will take certain time, then again put on the network, again this will take certain time, and this will take certain time. So everything takes certain time. So the time that is taken from the request from the client all the way to the servers, for the servers to process, and all the way back, there is a term for this. We call this as any idea? What do we call this as? There is a term for this. What do we call this? Any idea?
It's a response time.
Wonderful, wonderful. We call this as a response times. We call this as what? We call this as, let me see if I can write something over here. Go to slide, screen, and show next. No. So there is a very, very important term for this. We call this as a response time. Okay, the time taken by the servers to respond to your request. What is the response time? Time taken by the servers to respond to your request. Okay, so it's a response times. Popularly call it as transaction response times. Okay, and some people would like to call this as, you see, from this end all the way to this end. So they are calling this as end-to-end transaction response times. What do they? Some people call it as end-to-end transaction response time. Okay, simply some people call this as, they would like to call, they would like to write this as TRT, transaction response times, or just RT, response times. Okay, what is this? The response times. The response times is for what? Response times is for the transaction, so we call this as a transaction response times. Okay, by the way, this is internet, this is intranet. Okay, this is internet, which is used by anybody, everybody, and all the people. But this network is used by only the servers. This network is there in the data center. It is there in the data center and used only by these servers. Only by these servers. You listened to this word before? Did you heard this word? I mean, when I was there in the school, I used to have this term called inter-school competition. Okay, intra-school competition. there are any competitions. Okay, so these are the two things. One is inter-school competition, one is intra-school competition. Have you heard about this? Did you ever had these terms used by in your school days? Inter-school competition, intra-school competition. Inter is between two different schools. Okay, you have a cricket match or a football match or a soccer match. It is between two different schools. Okay, and intra is within the school. Intra is within the school. Same thing with internet and intranet. Or they say this, instead of saying intranet, they say this as local area network or LAN, local area network. Or let's call this as intranet. So there's no response from you guys. Are you able to hear me? Okay. At least you should have heard these terms, right? Intra-school competition and inter-school competition. Did you ever heard it during your school days? Like your 10th class, your 10th standard and all that?
Yes.
Okay. Yeah. So same thing. Internet means it is available for all the people. Just give me a moment, guys. Just give me a moment. Sorry about that, guys. Sorry about that. So you see, internet. This is internet, can be used by anybody. Okay, you can purchase it and you can start using that network. But this is intranet or the local area network, which is used within this data center and only for the communication between the servers. So this is the internet and this is the intranet. Okay, so this is the internet. This is the internet. Okay, and this is what is the intranet. Okay, so definitely we don't have any control on this. Depending on the client's internet connectivity, the request can travel. If he is having a very good, like a 5 Mbps line, 10 Mbps line, then the request will reach you fastly. Okay, so as for performance testing, this is one thing that you need to understand. Okay, if the internet speed is slow, definitely the response times will be slow. So we can't do anything about it. But if the internet speed is fast, but even when the response times are slow, this is when you have to worry about. This is when you have to think about. Okay, so that is what is the problem. Okay, so this is internet and intranet. Okay, so now we have established what is a transaction, what is a transaction response times. So I'll try to explain these two terms using an application. Okay, using an application. Watch here carefully, guys. I hope you are following me. I'm not getting any responses. Okay, so please respond back. Take some efforts to respond back, guys. Respond back to my questions. Okay, so okay, so you see, from the client you enter this URL and click enter. The request went to the server. Server has sent the response back and you are able to see this screen. You are able to see this screen. Okay, so this is one transaction. We can call this as a launch transaction. Okay, we can call this as a launch transaction. Now, as a user, you enter the username. No, this is not the transaction. You entered the password. No, this is not the transaction. Now you click on the login button. Now the request is sent to the server with your username and password. The server will process the request and send the response back. So this is a transaction. And it has taken certain time. The transaction, that time is the transaction response time. Okay. Now you see, you clicked on the flight button. You clicked on the flight button. Then a request is sent to the server. The server has sent the response back. That's a transaction, and it has taken a little bit of time for that. That's the transaction response times. Okay, so you entered the city. That's not the transaction. At least for this application, you entered another city, that's not the transaction. You selected business, that's not a transaction. You selected window, that's not the transaction. And you selected the date. Okay, so that's not the transaction. Now click on continue. A request is sent to the server. The server hasn't sent the response back yet. Okay, once the server sends the response back, then the transaction is complete. Okay, then the transaction is complete. Okay, so seems like there is an issue over there. Okay, you enter the city, you enter whatever it is, and click on continue. A request is sent and you get the response back. That's the transaction, and it has taken certain time for that. That's the transaction response times. Now you selected a flight. That's not a transaction, but once you click on continue, a request is now sent to the server. Server has sent the response back. That's a transaction, and whatever the time it has taken for you to display this page after you click on continue, that's a transaction response times. Okay, so that's what is the transaction and transaction response times. Okay, I've shown you from the front end. Here we have understood what is happening on the back end, and I've told you what is the transaction response times from the back end, but I've also told you what is the transaction and transaction response times from the front end as well. Okay, is it clear, guys, all of you? Is it clear, all of you? Is it clear, all of you? Yeah. So Majid has a question for us. I can say internet is between client and server, and intranet is between the servers. Yes. Okay. Internet is used by anybody. Intranet is used by only that company. If you want to get into the network, you will not have access to that. That kind of thing, we call this as an intranet. But internet, if you purchase this, you can get into it. Anybody can get into the internet as long as you purchase it. So that's the internet. Okay. So Majid, I hope I have answered the question. Okay. Shraddha, I know your still questions are pending. I'll definitely take those questions. Okay. Okay. So I'll take one question, Shraddha. In which case we have a separate web server. Okay. So I'll come to that. First of all, people need to understand that, the two servers together. Okay. Let me get to that point. Then I'll get to the point wherein, which case, we have the web server separate. Okay, so far we have completed so far here. Okay, so now let's look at some interesting things. Okay, so our Mark went to a theater. Okay, our Mark went to a theater to watch a movie. Okay, he liked movies, he watched a movie. Fortunately, unfortunately, let's assume it's in those days wherein there is no online booking. Okay, there is no online booking, and the only way we can get the ticket is go stand in the line and you get the ticket. Let's assume it's one of those days. In those days, okay, let's consider those days wherein there is no online booking. Okay. Now, hang on, guys. So some of the students have a difficulty joining. I'm not sure. It's the same link. Anyways. So there you go, guys. So there you go. So this is our Mark. Okay. He's standing in the line and there's a huge queue in front of him. Okay. So it's so pissed off, Mark. It's taking a lot of time. And there is a problem here as well. Not only that, Mark, there is a huge line. There is one more problem. The guy who is giving the tickets, okay, he's an old guy. He's an old guy. So what he has to do to process a ticket, first he has to take the money from him, okay, and he has to cut the ticket, and he has to find the change, and he has to give the ticket back and the change back. That's the processing this guy is supposed to do. What is the processing he's doing? The processing is he's taking the money, he's pulling out the chain, he's pulling out the change, or he's pulling out the, what do you call in US, the change? I mean, he has to give the change back to him, right? I don't know what the term that you use. Okay, so he has to give the remaining money, the change as in the remaining money. Okay, so he has to give the remaining money, and he has to give the ticket as well. So he's processing that. He's processing the tickets. So he's an old guy with the hands shaking and all that. So he's processing that very, very slowly. He's processing it very, very slowly, and our Mark is totally pissed off. Okay. Now the theater owner came to Mark and he said, Okay, so you see, Mark went to theater to watch a movie. There is a huge line, and a person has to wait a really long time to get the ticket. Okay, and moreover, the guy who is giving out the tickets is an old guy taking really long time to give one ticket. Okay, you see, watch this question carefully. I want everybody to answer this question. Okay, if you are Mark and have to give a suggestion to the theater owner to decrease the time for getting the ticket, what would that be? What would that be? Now you see, if you're Mark, it's taking really long time, right? So you have to give a suggestion to the owner of the theater, saying that, yeah, no online, no online. Let's consider those days there's no online. Okay, that's the first assumption we made. Okay, no more online. Okay, no more online. Okay, so what is it? Wonderful, guys. Increase the number of counters. Increase the number of counters. Wonderful. Okay, so multiple counters. Now the line has decreased a bit, and even now if it is more, you add two more counters. Even now you think that the line is really big and it's taking really long time, you add multiple counters. Okay, you need to add multiple counters. The same is the story over here. Okay, so let's assume a situation. Okay, let's assume a situation wherein okay, so the app server is taking a really long time to process the request. The app server is taking a really long time to process the request. Okay, just like this old guy. Okay, he's taking really long time to process the request. The line has increased. So here also the app server is really taking a really long time to process the request. So okay, so guys, sorry guys, to cut you in between. So we'll take a break of 10 minutes. I'll be back. I know we are in a juncture which is very, very interesting. The thing is, in this break, I usually go to drop off my kids for the school. I mean the school bus. Just that's the reason why sometimes I abruptly disconnect in between. I know I'm breaking in between without coming to the proper conclusion. Sorry about that. Okay, we'll be back in 10 minutes. Please take a well-deserved break and a very, very interesting things to learn after the break. I'm telling you. Okay, trust me, very, very interesting things to learn. Okay, so just take a 10 minutes break. In India, the time is 7:50. We'll be back at 8. Okay, sorry, 8 o'clock. 10 minutes from now. Okay guys, so let's get started after the break. So are you able to hear me and see the screen, please? Let me see the recording is happening. Yes. Are you able to hear me? And are you able to see the screen? Okay. So, so wonderful question, Chaudhary. Uh, what I will do is I'll create a WhatsApp group. Okay. So that all the students can join. So I have all your WhatsApp numbers, guys. So today I'll create a group and I will add all of you into that. Okay. And so that you can discuss with each other and see any issues like you have faced today. Okay, so let me make a note out of it, Chaudhary. It's a wonderful suggestion. Okay, uh, WhatsApp group. Okay, for students. Already there, I have some WhatsApp groups with the old batches. I'll try to see if I can add you into that groups. Okay, so that you can chat with each other to see like what is going on and all that. Okay, and also try to join at least 5 minutes before, so that if there are any issues, I'll be able to solve it. Like for today, Chaudhary has an issue and he just had to wait. Almost he has missed half of the class. So if you can join at least 5 minutes before the class, and if you are having any issues, I'll be able to resolve it. But after the class, I rarely check my WhatsApp messages and I will not be able to help you guys. Okay. So, yes, Shraddha, tomorrow, day after tomorrow, and then after that, 3 days off. Then the next class is after 3 days. Okay. So, so well, okay, there you go. So this is the final thing. Okay. Okay. Now, before the break, what we have discussed was if there was a bigger lines, you would add multiple counters so that the time taken for our mark to take the ticket will decrease. Okay. So here also we are having the same issue. Okay. So as the requests are coming in, it is able to handle the load, which means that the requests are being processed by the server very quickly. And this server is able to process your request quickly. Okay, what is the processing that this guy is doing here? He is taking the money, he's giving the remaining, he's pulling out the remaining money and he's cutting the ticket and he's giving it to the person. So there is certain work or the process that is done by this guy as well. Similarly, the server is also processing your request. It needs to understand the request, process the request, and sends the response back. Here also he needs to understand the request that you need the ticket, and he has to process the request, which means that he has to take the appropriate, he has to give the appropriate money back, and he has to give the ticket back, and he has to take the money from you. Okay, and finally send the response back, which means that he has to give the ticket back to this guy over here. So similarly, the server is doing the same thing. He's understanding the request, processing the request, and sending the response back. So this guy is fast. He's able to understand, process, and send the response back quickly. And this guy is able to do it fastly as well. But for whatever the reason, this is not able to do it that fast. Okay, he's not able to do the things that fast. So what you have given the suggestion over here is, okay, you add multiple counters. So here also it's the same story. You can add multiple app servers. You can add multiple app servers. If one app server is not able to take the load, one app server is not able to take the load of all the people. If it is not able to take the load, all the requests will be lined up. All the requests will be lined up. Okay, all the requests will be lined up, just like the line over here is increasing. Like that, all the requests will be lined up and the line will be increasing. And the line will be increasing. And this guy, this request will really take really long time because it needs to get all the requests processed before this request processed. Right? Just like our mark. All these guys needs to be given the ticket before this guy will be responded or this guy will be processed. So here also it's the same story. If you send this request and this processor is slow, that's the reason why there is a huge line before that, and all this request needs to be processed before this request is processed. So which means that the request is being taken lot of time. Okay, so it is taking a lot of time for this request to be processed because there is a huge line in front of him. So to solve this problem, what you said is you have to add one more counter. You have to add one more counter. I'm doing the same thing over here. We are adding one more app server. You are adding one more app server. Okay, why? Because some request out of this will go to here and some requests will be processed here, and there are no issues. Then the time for you to get this request process will be decreased, or in other words, the response time will be decreased. In other words, the response times will be decreased. Okay, I totally agree with your first suggestion that the counters has to be increased, but what is the second suggestion? Do you have any other suggestions so that the mark will be able to take the request very quickly? Okay, don't keep saying that, keep adding the counters. Okay, we can say we can keep adding the counters, but what is the other suggestion? Is there any other suggestion? Pay attention. What kind of guy this guy was? Is he processing the request fast or slow? Is he processing the request fast or slow? So he is processing the request. Phil says superhuman. Okay, this is an old guy slowly processing your request. So you replace that with a superhuman is what Phil says, but not superhuman. Somebody, a young chap, who is able to, quickly, get the younger guy in there. Okay, so that he will be able to process the request. Okay, so process the request. Similarly, here also, the old guy means the processor typically contains what? And a server contains what? An app server, a processor, okay, a RAM, sorry, not RAM, memory. Okay, you can call this as a RAM or memory. Processor, memory, okay, you can either call it as a RAM as well. Processor, memory, and hard disk, or just disk. Okay, so older guy means some old, weak processor. I wouldn't say old processor, a weak processor like i3 dual core and all that. Okay, so young chap means better processors. Okay, i7 and all that. Okay, and old guy means less memory or less RAM. Okay, and young chap means sufficient memory. I wouldn't say too much memory, but sufficient memory, which is just suitable for your application. Okay, so what you have to say is, if it's an old chap, or the app server is not able to do the work, definitely the processor is not able to process your request fast, which means that you have to upgrade your processor, and some cases it could be memory issues as well, so you have to upgrade the memory. But only to certain extent you can upgrade the processor or memory, right? So the fastest processor is also not able to process. Then what you have to do? You have to add one more counter. You have to add one more counter, or you have to add one more app server. Okay. So what is the first suggestion? Replace the old guy with the young guy. Okay, which means that improve the processor, improve the memory, but still the line is big enough, and it's not able to process your request, or the guy who is coming in is really taking a lot of time to get his tickets, then definitely add one more counter. Here also, instead of Mark, what we have is a request. So the request needs to be served fastly so that the response times is high. So let's assume from the client you have sent the request for the launch page. The request has come over here. This has processed quickly and sent the request to the app server. There is a huge line in front of the app server. Now your launch request is lying there. So now the launch request will be served only after all these requests are served, which means that it is taking a lot of time. Then once this time comes, it will process the request, sends the response back, and finally the web server sending the response back. That's when you will be able to see the launch page. So if this line is big and if it's taking really long time, then the launching of the page happens very slowly as well, which means that as an end user, you find this application very slow. Or in other words, the transaction response times for your launch request is really high because there is a huge line in front of the app server. So what is the first thing you do? You upgrade your processor and the memory. That's what we call it as scale up. What do we call this as? Scale up. Okay. What do we call this? Scale up. So you upgrade the existing hardware. Upgrade the existing hardware. So usually that's the first thing that will be taken. I mean, if your hardware is the issue, usually that's the first thing typically the developers will look into. And the second thing is scale out. Scale out. Out means completely you're adding one more app server. Completely you're adding one more app server. Okay, scale out. You're adding one more app server altogether, so that some request will go to this app server 1 and some request from the web server will go to the app server 2. Okay, and also remember guys, I didn't put this, I haven't set this expectation yet. Also remember that concurrent means multiple clients at the same point of time. In this picture we have been looking at only one client, but when we are talking about concurrency, we have multiple clients who will be sending all the requests. Okay, will they be sending the same request? No, whatever the request they want, they will send it. But it's the same application, it's the same Facebook application. This guy can send it for launch page, this guy can send it for login, this guy can send it for logout, this guy can send it for maybe posting something on the wall. So different guys will be sending different requests. So all these requests needs to be sent. Let's say there are 4 of them, all the 4 requests concurrently. Concurrent means all of them are accessing your application at the same point of time, which means that all of them are sending the request concurrently or simultaneously. So now this web server has to serve 4 requests, and the app server at a point of time has to serve 4 requests, and if required, probably the database server might be processing or need to process this request. May not be all the 4, probably 2 or maybe 3. Okay, depending upon the request. So that is the reason why you need to either scale up or scale out. So you have done the scale up whatever you could, you cannot do anything more, so you have to scale out. Now when you scale out, all the 3 requests will not come to the app server 1 itself. Some of them will go to the app server 1 and some of them will go to the app server 2. So how is this being sent? How is this being sent? We'll look into that. How is this being sent? We'll look into that. Okay, so far it is clear guys. We have assumed that the app server is not able to handle the load. It's like your old guy giving the ticket. So what we have done, we have tried to scale up, which means that upgrade your processor and the memory, and it's still not working out. Then we have scaled out, which means that we have added one more app server. Still not able to add one more app server. Is there a limitation? No. In the last project, I have 2 web servers. In the last project, I had 2 web servers, 4 app servers, and then 2 database servers. 2 DB servers. So this is my architecture of my last project: 2 web servers, 4 app servers, and 2 database servers. Okay, just that if app server is the only one which you can scale out, no, you can scale out any of that. And this was the architecture for my last project. Okay, so you can talk about that. Definitely in the interview they will ask you what is the architecture of your application in your last project. Okay, definitely you can talk about it. Now you know why we are not calling this as a 4-tier, why we are calling this as an N-tier, because you can have as many tiers as possible depending upon the load criteria. Okay, Phil, I'll take that question. Okay. So far is it clear guys? So far it is clear. Any questions so far? Shraddha, one question from you is pending. I still remember. Don't worry about that. Any other questions on this particular slides that is covered? Any questions guys? Okay. The definition of scale up and scale out is what you wanted me to repeat, Melly. Melly? Okay, so the entire architecture, as I've told you, I cannot give you a definition, but I can explain this. Okay, so entire architecture is, as you can see here, there are 4 tiers: 1, 2, 3, 4 tiers. So ideally you wanted to call this as 4 tier. Okay, but entire means you can have any number of tiers. You see, you scaled up and you have added one more app server. So now how many tiers you have? 1, 2, 3, 4, 5 tiers. And it's still not enough. You have added one more tier. Now you have 6 tiers. So like this, you cannot say 4-tier architecture, 5-tier architecture, 6-tier architecture, 7-tier architecture. You can't keep naming and you can't keep giving those names. So they have generalized it. Up to 3 tiers, it's 3-tier, but anything more than 3 tiers, they have generalized it as 4-tier architecture. Anything greater than 3 tiers, they are calling this as entire architecture. Sorry if I say 4-tier, I'm sorry. So it's entire architecture because there is no limitations on the tiers. You can keep adding depending upon your load profile. Millie, is that fine? Did I answer that question? Yeah, thank you. Okay, wonderful. Yes, Phil. Yes. Okay, but it can be done horizontally as well. Okay, it can be done horizontally as well. In my experience, Phil, they say two things. How are you scaling, vertically or horizontally? Okay, so when they say scale out, they're adding one more server. They either say, whether you're doing vertically or horizontally. Okay, so I'll come out with a real architecture where is the horizontal scale up. Phil, that at that point of time you'll understand, the horizontal. Just now I've shown you the vertical scale out, right? So I'm going to show you the horizontal as well. Okay, so probably Phil, tomorrow I think that will happen when I come to a real-time architectures, how they look like. So I'll come to that tomorrow. So I'm going to show you one of the architectures. Okay, and then probably you can use that for your interview purposes in case if you wanted to. Okay, so far it is clear, guys. So far it is clear. So you see, in my last project I had 2 web servers, 4 app servers, and 4 app servers, and I don't remember 2 or 3 database servers. Okay, so scale out need not happen just on the app server, but usually happens. It could happen on the any servers or any tiers as well. Okay. Now you see carefully, guys. Okay, let's go back to the picture wherein there are more counters. Let's go back to the picture wherein there are more counters. Okay, you see, this is counter 1, this is counter 1, and this is counter 2. In this counter there are 4 people, and this is counter, there are 2 people. If there is a new guy coming in, okay, let's say there is a security guy standing before and is driving the people into right counters. Okay, if the new guy has come in, this is our Mark who has come in. Now you tell me, this security guy, should he send Mark to the counter 1 or should he send Mark to counter 2? Which counter he should send Mark to? If you are the security guy, counter 2, wonderful. Why? Because there is less load on counter 2 and more load on counter 1. Ideally, now Mark comes, the security guy should send him to the counter 2 so that it's equally loaded. Both the counters are equally loaded. Similarly, there is a concept called load balancer. Which works just like your security guy. In this case. What is the security guy doing? He's continuously monitoring the load. He realized that counter 2 has less load, counter 1 has more load. So the new request coming in or the new guy coming in, he's sending it to the counter 2. So what is this security guy doing? 2 things. One is continuously monitoring the load of the counters, and when there is a new guy comes in, he will send it to the counter when there is a less load. So load balancer works in the same way. So in my example, I've taken app server. I've scaled out the app server in the previous example. In this example, let's assume we have scaled out the web server, which means that web server was not able to take the load. So you have scaled up the web servers. Why? Just because I wanted to give you a feel that it's not just app servers you can scale out. It's a web servers also you can scale out. Because some people after this class, they will be in the impression that, oh, app servers is the only one which we need to scale out. No, you can scale out any servers. Just to reiterate that or reinforce that point that web servers can be scaled out as well. So I have added this slide. Okay, and typically the load balancer will be before the web servers, guys, in the real world as well. Okay, so that's one of the reasons why I have taken this picture and scaled out the web servers. So you see, the web server was not able to handle the load. The app servers was able to handle the load. The database server was able to handle the load. Since web server was not able to handle the load, you have scaled out the web servers. So which means that there are 2 servers. Now there are so many clients who are sending the request. It's not just one client. When there are concurrent users, which means that there are so many clients which are sending the users. Let's say this is client 1, client 2, client 3, client 4 and client 5. Okay. Now different clients are sending the request. All these requests, okay, let's assume a picture when there is no balancer. Okay, so all these requests, they don't know which server to go to. There are two servers, okay, web server 1 and web server 2. Okay, if they randomly go to a different web servers, then load cannot be balanced. So this is the reason why there is a load balancer. There is a load balancer before the web servers. There is a load balancer before the web servers. Now what happens? All these clients who are sending the request, first the request will go to the load balancer. The load balancer works like your security guy. What is the security guy doing? He's continuously monitoring the load of the counters. Okay, he realized that this one has the less load, so he has sent the new coming request or the new guy into the counter 2. Load balancer works the same way. It continuously keeps the tab of both web server 1 and web server 2. Let's say the web server 1 is highly loaded. Let's say the CPU utilization over here is 90%. Okay, the CPU utilization is 90%, or in other words, the processor is being used 90% of the time. The CPU utilization is 90% means the processor is the one which will process the request, right? So the processor is 90% occupied, which means that this is doing a lot of work. And here let's assume the processor is only 40%. Okay, the processor is only 40%, or the CPU utilization is only 40%, or in other words, in the layman's language, this is doing less work and this is doing more work. How can we know this is doing more work? By looking at the processor utilization. This is 90%. And how do you know this is doing less work? By looking at the processor utilization, which is 40%. So the load balancer will continuously keep tab of these two things. Okay, and it says that this is 40% utilized, this is 90% utilization. So definitely this can do more work and this cannot do any more work, because hardly there is 10% left. It is keeping busy 90% of the time. You see, there is good amount of work it can do here. So the new request comes in, okay, it directly goes to the web server 2. And who will make sure it goes to web server 2? The load balancer. And the name is also saying that. What is it saying? It is balancing the load across what? Across two web servers in this case. What is it doing? It is balancing the load. What is it doing? Balancing the load. Balancing the load across what? Balancing the load across the web servers in this case. So have they appropriately named it or not? Yes, they have appropriately named it as a load balancer. Why? Because it is balancing the load across two servers. If there were four web servers, it would balance the load across all the four web servers. Okay? It will balance the load across all the four web servers. So, how does the load balancer know who has sent the last request to correspond the next request to the same user? Okay, it's a difficult question, Phil. So there are some algorithms. Okay, I was about to come to that point, and see, there are some algorithms which are there inside. Okay, one of the algorithm is via IP. Okay, one of the algorithm is via IP. Okay, so one of the algorithm is via IP, but this is not being used anymore. Okay, so the request Okay, I'll take this question after the class, Phil, because a lot of people will get confused. So Phil, I'll keep your question aside in my questions basket. Along with Shraddha's question, I'll take your question. Okay, so because some people will get confused. Okay, but just now on the high level, what I would say is every load balancer, there is an algorithm inside that. Okay, again, load balancer is again a combination of hardware and software. There is an algorithm which takes care of all the things. And one of the old algorithms is IP. Okay, based on IP. But this is not used anymore. This is the reason why there is a concept called IP spoofing as well in LoadRunner. Okay. No, Shraddha. No. That's a wrong assumption. I'll come to that. Okay, I'll come to that. there is a different question as well from you, but after the class I come to that because there's certain students who might get confused if I get into those areas. Okay, so there are 2 questions in my basket, but I'll take those questions after the class. Okay, so last topic for the day. I'm wrapping up, guys. So last topic for the day. Yeah, next one is a protocol. So we'll take that tomorrow. Okay, look at this very carefully. In the real world, typically we don't have a web server and app server. Now I can take Shraddha's question after this slide. Okay, I was just waiting for this slide to get completed. So in the real world, honestly speaking, there was only one project wherein the web server separate and app server separate, and it was completely up to the developer how they wanted to do it. But in the real world, typically we have web app servers. Okay, so the picture that I've told you that I had 4 web servers, 2 app servers, and 3 database servers. Honestly speaking, for me in my project, there were 4 web app servers. Okay, okay, and 2 database servers. This was the architecture for my application. Okay, in the real world, typically we don't have a web server, app server separately. These days, they take one server which will do the work of both web and app. So we're calling this as a web app server. Okay, we're calling it as a web app server. So even the available servers are also like that, web app servers. So that is the reason why most of the people go with this. Why? Because the kind of work it would do. Okay, the kind of work it will do, if they are both of them are put together, it is very, very easy rather than having it at different places. Okay. Now Shraddha has asked a question, in which cases it is separate, which cases it is combined. Shraddha, it is totally up to the architect. During the architecture, he will decide, depending on the application, whether he wants it different or whether he wants it same. But I haven't seen the architecture in the recent times wherein web server is different and app server is different. Okay, so I haven't seen, in the latest architectures, all of them are web app servers. We have Chaudhary in our class, who is on the infrastructure side. So Chaudhary, can you throw some light on this? You have been working on that infrastructure, on the environment side. So do you see these days, the web server, app server separately, or even Phil can answer. Phil is into all this. So you guys can feel free and add some comments over here. At least in the last few projects, from last 3-4 years, I haven't seen a project wherein web server separate, app server separate. All I have seen is web app servers. So anybody who has some knowledge on this, they can throw some light. So maybe Phil or Chaudhary or Krishna is also working in the industry for long. Okay, so so anybody who is there in the industry for long, you can add the comments here. And Srivalli is also into this coordination and all that for a while. Okay, so she can also throw some light. Okay, Phil says web server combination is common. That's what I felt. Every single project that I am involved in, it is web app servers. We have same web and app server together. Chaudhary is also saying the same thing. Yeah, so this is the common thing, Shraddha, web app server together. Because when you go to the market as well and you wanted to buy, the things which are is web app servers available. Okay, so that is the reason why, very rarely, I think only Apache HTTP server is the only separate web server. Otherwise, it's all web app servers, what you available in the market. Okay. So Shraddha, I hope I have answered that question. Okay, and definitely it's not performance testers who will take the call as to whether you should have a separate web server, app server, or you should have a combination of web app servers. It is totally up to the developer. Okay, again, I'm telling you, all the applications that you're seeing, okay, those are all web app servers. Okay, so behind the scenes, we don't know. Honestly, Facebook will never expose its architecture to us, or Gmail, or LinkedIn. They don't expose their architectures to the outside world. But these applications that you're seeing, more likely than not, they have the web app servers inside. Okay, so I can't really give the examples because nobody will expose their architectures. But the applications that I have dealt with recently, I've done a project on a banking online application, and it has the web app servers. So most likely the ICICI online banking that you have seen, it will definitely have the web app servers behind the scenes. Okay, I can say only most likely because I don't have the architecture of ICICI banking, and there is no way I can get it. They won't expose it. Okay, but most likely all the web applications that you're seeing, that you're accessing, they have the web app server. Some of them which are built old, they could have a web server, app server separately, but we will not be able to, will not be 100% sure because nobody exposed their architecture to the outside world. Okay, but in the interview you can say that, I worked on the online ICICI online banking application, or maybe some Amazon shopping or some shopping website, and you had the web app servers, because most likely that's how it will be. Okay, now let's go back to this. Okay, the web app server, let's go back to the web app servers. Okay, so let's observe, or let's see what is there inside. Okay, let's see this. Okay, watch carefully. So we know on this web app server, okay, I'm not sure, Phil, I don't even know what is there behind the scenes for mainframes. I was never involved in any mainframe application, Phil. So I don't even know what is there, but it could be a client server is what I'm thinking, but I'm not quite sure. Okay, it's a old stuff. Mainframes means it's legacy. Okay, people still use it because it's safe. Otherwise, it would have gone long time back. You go to any financial, okay, any online finances, insurance, you have mainframes because it is the most secure thing available on planet Earth. Okay, so nobody can match mainframe security. But I don't know the architecture because I never honestly is there. Okay, so Srivalli says it's a 3-tier. Okay, she has a good knowledge, Phil, on this. Okay, she has been working in that area for quite some time. Okay, so I'm deviating a little bit, guys. Just give me 5 minutes, then we can have this discussion. Okay, just give me 5 minutes, and we'll have these discussions. Okay, so now we know on this web app server, a developer, okay, will create a code. He will write some code. Okay, he will write some code. Let's say it's in the Java application, and that code will go on this web app server. We'll know that. Okay, this code going on this web app server, there is a term for that. What is that term? You're putting, the developer has created this code, and let's say that is in the Java programming language, and he is putting that code on this web app server. There is a term for that. What is the term? Deployment. Wonderful. We don't call it as installation. We don't call that as installation. We call that as deployment. I'm using the mouse to write this, guys, so sorry with the handwriting. Okay, so you have to put up with that handwriting. It's called deployment. I hope it's still legible. Okay, we don't call this as installation. We call that as deployment. Before that code is deployed, I'll start using the word deployed now, guys. Okay, I'll start using the word deployment or deployed or deploying or all that. Okay, what is deploying? Putting the code that the Java developer has created on the web app server. That process we are not calling as installation, we are calling it as deployment, because the steps are different. For the installation, you get an exe file, you click next, and finally say finish, because that's installation. But the deployment is different. Okay, the process is different, but both of them is same, attaching the software with the hardware. Since the steps are different, they have given a new name called deployment. Okay, so let's start using the word deployment. The developer, you see, the developer is always a happy guy, you see. Okay, so he has created the code and he has put. Tester is little not happy. Okay, why? Because this is when, once the deployment is done, he will start his work. Okay, once the deployment is done, he will start his work, and he has to find the faults. Okay, actually the tester should be happy because he's always finding the faults. Okay, finding the faults of the developer. So let's put the developer like this. Okay, because he's unhappy because this guy is finding the fault and he has to keep rectifying the faults. Okay, so this guy is our developer. This Java developed a piece of code on his machine in Java. So what he is doing is deploying in the web app server. But before deploying, what we have to do, what the developer has to do, he has to install this web app server. There are popular web app servers available in the market. You can purchase it from any one of them. Like the databases, before you can start storing the data, right? Before you start storing the data, don't you install that software on that? Don't you install a software called Oracle or something like that on that? Yes. You can't start, you call this as a database server only after you install a software called an Oracle or a DB2 or something like that. Similarly, you have a machine, you can call this as a web app server only if you install a software on this. Okay, then you can deploy the code. Similarly, once you have taken a hardware, you can't start storing the data inside it. You can't start storing the data inside it until you install some software like an Oracle or something like that on that. So once you install the software called Oracle on that, then you can start storing the data, and if you want, you can retrieve the data as well. Similarly, the Java guy has developed the piece of code. You cannot put the Java code on this hardware. You have taken some hardware, let's say your desktop, okay? You can't put the Java on that directly. First, what we have to do? We have to install a web app server on that. We have to install a web app server on that. There are so many available in the market, like, Apache, Tomcat, JBoss, WebLogic, ISS, WebSphere, and all that. So, what is the first step? Install this web app server on this. What is the first step? Let's say this is your web app server, guys. Let's say this is your web app server. Hang on. Okay. Let me take the paint. Okay. Now let's say, watch here carefully, guys. Let's say this is your web app server. Watch here carefully, guys. This is very, very important. Okay. Now we have a wonderful developer who has created a code. Okay. So we have a developer here. Okay, so we have a developer, and what he has developed? He has developed a Java code. Okay, so he has developed a Java code. Now what he will do? What he has to do? He has to deploy that code on the web app server. Can he do it directly? No, he cannot do it directly. Now first, what he has to do? From the market, he has to buy. Okay, a web app server. From the market, he has to buy a web app server. In the market, there are a lot of web app servers available. Okay, the popular one is Apache Tomcat. Okay, Apache Tomcat. Okay, so he has to buy something. Okay, Apache is the company name. Tomcat, okay, is the product name. Okay, or WebSphere. I think WebSphere belongs to IBM. Somebody please correct me if I am wrong. Okay, IIS. Okay, and what else are there? WebSphere, WebLogic, JBoss. Okay, JBoss. Like this, there are a lot of available web app servers. The architect will decide which one they wanted, depending on the pricing, depending on your project, depending upon the programming language that you have created. Okay, so suppose like Java is there, maybe ISS might not be the right one. If it's .NET is there, ISS is the right one. Like that, there are a lot of ifs and buts. With all those, they will come out with a solution. They will come out with a product. Other than that, there are a lot of them. Okay, these are not the only ones. There are a lot of them, but these are the popular ones. Let's say for this project, they have decided Apache Tomcat is the web app server. So now Apache Tomcat, first you install on your hardware. Okay, Apache Tomcat, first you install on the hardware. Okay, nice. Okay, so you took a hardware which is a server. On that hardware, what is the first thing you're doing? When I said you, the developers or the infrastructure team, they install the Apache Tomcat. Now the developer can deploy this piece of code over here. Now the developer can deploy this piece of code which he has written in Java over here. Okay, so now the deployment is done. So you can do. We are almost done. Okay, I don't want it to break in between. We are almost done. Okay, so there you go. You see, now your web app server is ready. How can you say it's a web app server? You take any hardware. It could be a desktop, laptop, or a proper server which has a very, very powerful processing speed and the memory. Now on that, you decide depending on the programming language, depending on the price, depending on how much you can afford. You will buy one of the web app servers which are available in the market. Apache Tomcat, WebSphere, ISS, WebLogic, JBoss, and lot of them are there. Let's say you have decided Apache Tomcat. First you install that. You don't deploy that. You install the Apache Tomcat because it is next. Okay, you click on next, then you click on next, finally finish. Now the developer developer has developed the Java code. He has some lines. So he will go ahead and deploy it on the, now this is the Apache Tomcat web app server, because on this hardware Apache Tomcat is installed. So you have an Apache Tomcat web app server. On this you deploy the Java code. You deploy the Java code on that. Now the deployment is done. Now you can call this as a app server. Now your app server is ready. Now your app server is ready. Okay. Similarly for the database as well. Okay. You take a machine, any machine. Okay. You can't right away start storing the data. You can't right away start storing the data. Okay. You can't right away start storing the data. Okay. What you do then? You go to the market, buy one of the softwares. Let's say you decided to have Oracle on that. So you go ahead, buy Oracle and install the Oracle. Install the Oracle software. Install the Oracle software. Okay. Okay. So you install the Oracle software on that. Now this has become an Oracle database. This has become an Oracle database. Or I don't know how do you spell it appropriately. I would like to say it as Oracle. Okay. So now you have an Oracle database. Now you can start putting the data in the form of different tables. Okay. You can start putting data in the form of different tables in that, and you can start storing all the data in different tables. Okay. So now your database server is ready. Now your database server is ready. Okay. So why I am telling you this is, do some research on all the web app servers available in the market. Do some research on all the databases which are available in the market, along with the versions. Because in the interview, when they ask you what is your architecture of the last project, what is the architecture of the application of your last project, they are expecting which web app server you are using along with the versions. You can say that I have used in my last project, it is Apache Tomcat blah 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 version and an Oracle database blah 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 version. Okay. So do some research on all the web app servers and the database server along with the versions, along with the version names, because in the interview you are expected to give them the answers as to which web app server. You just say web app server, it's not good enough. You have to say which web app server with which version and which database server with which version, and how many web app servers are there and how many database servers are there. This is when the answer is complete and he will not ask you any more questions. Okay. This is the reason why I am spending so much time on this explaining. So what is the homework for today? What is the homework for this weekend? Do all the research on the web app servers along with the versions and see which year which version has come out. And same thing with the Oracle, which year which version, not Oracle, database servers, all the database servers, which year which versions. And also one more thing. Okay. If you're saying the programming language as Java, which web app servers are supporting that? Okay. Which web app servers are supporting that? And what are the versions for that? Okay. If you're saying that your programming language is .NET, okay, which web app servers supports that? Okay. And the version of that. Okay. With the years as well. Okay. Which year? Because I have seen when I'm taking the interview, I have seen that, okay, we have worked, okay, these are the silly simple tricks, I want you to be aware of, guys. Okay. So he said, oh, my project has started in June. Oh, okay. Sorry, his project has started in June, 2010. Okay. And he gives the latest version of Oracle, which is not possible because in June 2010, the latest version of Oracle is not there. Okay. Whatever is the latest version of Oracle, let's see. Okay. So the latest version of Oracle is 10.2. I hope it has the release date as well. Okay. Somewhere you have the release date as well. I wish they give you the dates. Yes. Okay. So the latest version of Oracle is 18.1.1 and it is released in February 2018. So you say that your project is, you have started working on a project from 2010 to 2012 and the version of Oracle that you have used is 18.1. Is it possible? No. Is it possible? No, because Oracle is released in which year? February 2018. And you said you have put the project, you have worked on this project from 2010 to 2012, you're gone. So this is the reason why I want you to do the research on the years as well. The versions, the years, and Java supports which web app servers, .NET supports which web app servers, because usually your programs are written in Java and .NET. Okay, so this is the homework for the weekend, guys. So we will see you after 3 days. Okay, if you are in US, I'm expecting to see you on Monday evening, and if you are in India, I'm expecting to see you on Tuesday. I will send you a new link. Whatever the link that I have given you, it will continue to work, but nobody will join that link. Okay, I'll give you a new link. Okay, and people who haven't processed the payment, please process it so that you get the new link. Okay, and you can talk to me as well if you have any issues with the payment and all those. Okay. Shraddha needs day one report. Please send out a mail, Shraddha, so that I'll respond back to it. I usually forget. Now I'll take the questions, guys. Now is the right time to take the questions. Okay. So the people who wants to leave or in a hurry can leave. The other people, we can have the questions. Okay. Melly has a question for us. Melly, I hope you're listening. What is the question she has asked? In the real world, by the way, I hope everybody understands the assignment. Please take the assignments very, very seriously. Okay. Melly has a question. In the real world project, how would I know what kind of architecture is used for the project I am working on? Melly, this answer is for you. Okay. Melly, this answer is for you. Typically, any project would have a document called technical design document, popularly called as TDD document. What is it called? TDD document. Melly, I hope you're listening to what I'm saying. Melly, are you listening? Knock, knock, Melly. Are you there? Oh my God. You can just say hi, Melly. No, she's not listening. When she's ready. Okay, I'm here. Wonderful. Okay. So, Shraddha, please hold on. Phil, please hold on. I'll take your questions. Okay. There is a document called technical design document. Typically, once an architect comes out with the architecture, okay, of your application. Okay. How he can come out with the architecture? By looking at the requirements. Okay. By looking at the requirements of the client, he will come out with the architecture of the application. Okay. The client says, oh, I need my application to be to handle a load of 3,000 concurrent users. Then appropriate architecture will be selected by your architect. So various factors will be there before deciding upon the architecture. But once he comes out with the architecture, he will document that. He will document the architecture. In which document? In the TDD document. Okay. You will document the architecture along with the picture and all the explanations required for that in the TDD document. This document will be shared across every single guy in the project. Okay. Are you a manual tester or a functional tester or a systems tester, system integration tester, performance tester, security tester, different developers and admins and infrastructure team, database admins, network admins? It will be shared across all the guys. Okay. Definitely it will be shared across the performance testing team as well. Okay. If it is not shared, you have every right for you to ask for the document. It should be there in the shared folders of the document. Usually all the documents related to that project, they will put it in something called a shared folder. Okay. And since you are involved in the project, you will have access. Okay. So you will have access to the shared folder and you can go to that, or at least they will give access to it. You can download the document and you can study the architecture document. And one of the expectations before you start the performance testing is somebody will walk through. Okay. Somebody will walk through the architecture. Okay. Or in other words, explain the architecture to you. okay, architecture to you, okay, before you start the project, because that's very, very important for the performance testers. Okay, so the walkthrough could be done, a business analyst, business system analyst. The walkthrough usually will be done by whom? A business system analyst, popularly called it as BSA, okay, or a developer, okay, or a senior developer, or the system architect itself, okay, depending on the company, okay, a senior developer or a system architect. So somebody will walk through, not only they give the document, okay, but they will walk through as to what is what and all that, because there are different kinds of architectures. By reading, you might not able to understand sometimes. So you will request for a walkthrough, and you have every right for the requesting for a walkthrough. Okay, as a performance tester, you can request. In case they are not doing it as a process, you have every right for for asking for the walkthrough. Somebody will, your project program manager will decide. Somebody like a business system analyst or a senior developer or system architect will walk through that architecture so that you will understand that. Okay, Melly, is it okay? Did I answer the question before I take the Phil's question? Wonderful. Next, Phil's question. Is the architecture always considered the number of concurrent users the system is anticipating to handle? Typically, Phil, okay, there is not the only thing. There are so many things that needs to be handled, okay, that needs to be considered, okay, when you are deciding upon the architecture, okay, like how many third-party components that you need to trigger, and are there any web services, so there are so many things. Are you making use of any of those classes or the libraries or the jars which you already have in the company developed by somebody else? Or you want to consume them? There are so many factors which will decide the architecture of the application, and one of them is definitely the concurrent users. And where this concurrent users comes into picture is the hardware. Okay, when they are coming out of the hardware, deciding on the hardware as to what kind of processor you have to have, what kind of memory you have to have, and the disk you have to have on the servers, when you have to decide upon that, concurrent users plays an important role. Okay. Typically there is, Phil. I mean, there should be, right? Unless it's a new project or a new application altogether, there should be typically. Otherwise, like, how can we do performance testing? Or the client should have a ballpark idea once this application goes live, how many users will be using it. If it's a new application, if it's an old application, definitely you have the history using the web server. I mean, on the web server or the web app server, you have the history. You can use the tools like what do you say? There are some tools. I forgot. Okay, it starts with S. It's already installed. Just give me one moment. Um, uh, Splunk, right? Splunk. There are tools. Thank you, Vikram. There are tools like Splunk, okay, wherein they can go look at the history and they see, how much it has improved from last month to this month or last year to this year, and they can speculate what it will be next year, and then you can come out with the numbers. Okay, but definitely you have to have some numbers. Okay, if there are two kinds of project, one is it's already live, and for that we need not have to understand the architecture. I mean, you need not have to design the architecture because it's already there. Okay, and something which is completely new. If it's new, then the client has to have a picture as to what are we developing for, how many users we are developing this application for. So he has to give that. Okay, the client has to speculate. Okay, and come out with some numbers. Okay, come out with some numbers. If it's already an application which is old or which is already live, the architecture is already been done, let's not worry. But for performance testing, what we do is we go to Splunk, okay, look at the logs, okay, web server logs, okay, and we look at the history, okay, as to what it is this year, last year and the last year, and see by how much percentage is increasing, and we predict the future load, okay, based on the history. Okay, so now you have the numbers. So for both the cases you have the numbers. Okay, wonderful. Okay, so that is the thing. Susie, I'll definitely make you as a presenter, but there are two more questions. Okay, so one thing you have asked, Phil. Okay, so how does my load balancer, okay, how does my load balancer know that the first launch request has come from this client? Okay, you have sent it to web server 2 request, and the login should be sent to the same web server as well. So is that the question? Is that the question? Yeah. So there is an algorithms which are there. So one of the old algorithms is based on the IPs. So what it will do is it will store the IPs. So every client will have an IP. Do you agree with me, Phil? Every client will have an IP. Yeah. Do you agree with that? Yeah. So let's say this IP address over here. Okay. The IP address over here. Let me draw. I come to everybody's questions, guys. So just hold on. This is very interesting questions, but little advanced. If you're not able to understand, it's still fine. But if you're able to understand, that's even better. Okay. So now, yes, using the sessions and all that. Okay. So internally, I'll not be able to tell because I'm not a developer or an architect, but I'll tell you logically what happens typically. Okay. So we have different clients. Okay. Different clients. Okay. And we have a load balancer here. Okay. And we have two web app servers here. Let's not worry about the database server. Okay. So we have different clients. Okay. So let's say we have client 1. Okay. And we have client 2. Okay, client 3, and we have client 4. Shraddha, please hold on. Shraddha, I'll come to you. Okay. Now, every client has an IP address. Okay. Let's say this is 192.168.1.2. Okay. So let's say that's the IP address of this one. Okay. Now this one has an IP address as well. Okay. So 192.168.1.5, let's assume. Okay. So everybody has their own IP address. Okay. So this has this one, and this one has its own IP address 192.168.1.6, let's assume. Okay. And this one will have its own IP address. Okay. It will not be serial, but I'm putting it as serial. Okay. So let's say it is 5.8. Now, if the algorithm on the load balancer is based on IPs, if, watch that sentence, feel carefully, if, okay, it's no longer being used, but at some point of time when I was doing, that was one of the popular ones. But these days they don't use it, is what I heard. But if the algorithm is based on the IP addresses, my load balancer, okay, there is an algorithm which is written so that it keeps tracks of that IP addresses, and in case the first request which is sent from this IP address is sent to the web app server 2. Okay, this is my web app server 1. Sorry, web app server 1. Let's say this is my web app server 1, and this is my web app server 2. Okay, so this is my web app server 2. Now let's say the request coming from this 192.168.1.2, for whatever the reason, the load balancer has sent this request to this web app server 1. Okay. Now it will keep a note out of this IP address, and all the requests coming from this will go to the same web app server 1, irrespective of the load of these two. Okay, so that's how the load balancer, there is an algorithm that is written. So this is the reason why IP spoofing is very important in certain cases when we do performance testing. Did you heard about the word called IP spoofing, Phil? Did you heard about a term called IP spoofing? This is a purely performance testing word. Okay. So only if the load balancer algorithm is based on the IPs, then IP spoofing is necessary from when we apply the load. But the load balancer can use so many other algorithms which are there, which is very complicated, efficient. Okay. So if they are using that algorithms, then we need not have to worry about IP spoofing. You need not have to worry about IP spoofing. As you said, it could be based on the sessions and the cookies and all the other things. So I honestly, I'm not an expert in this one, but I can tell you that there are other efficient algorithms right now available in the market, and IP spoofing is not, IP spoofing algorithm on load balancer is a very old way of doing it. I don't think it is used now. Okay, so if your load balancer is using if load balancer algorithm is based on the IP, then definitely you have to do IP spoofing for our performance testing. If the load balancer algorithm is not based on IPs, then you need not worry about the IP spoofing. But there are different algorithms which are there on the load balancers, okay, which are very efficient and very performance efficient and very handy. Okay, did I answer that question, Phil? Okay, thank you. So now the next question. Okay, so let's go back. Shraddha, are you there? Shraddha, are you there? I'm browsing through so that I can get to your question. Shraddha, can you say hi or just ping saying that you're there?
Yes, I'm there.
Okay, what was the other question? I'm searching through the complete chat history. Can you please post it again?
Yeah, I was just asking what is the difference between the web server and app server? This is the internet and intranet difference only there?
No. Internet has nothing to do with that. Okay, so Shraddha, watch carefully here. Intranet is net. You see, this is all the data center. Okay. Okay, so Shraddha, watch carefully here. This is the data center. Okay, what do we call this as? Data center. Okay, so which means that the data center is, let's say, in Mumbai or let's say Pune. Okay, this is the place in India, Pune. Okay, so all these servers are there at one place and they are connected with each other. Okay, so you will not have access to this network because this is internal to that company and internal to the data center. You cannot get into that. Okay, so that's why I'm calling this as an intranet. Okay, but you see, this is internet. The request has to be put on the internet, send it to this data center. Let's say this data center is there in Pune and you are browsing from New York. The request will be put on the internet, will be sent to this data center which is there in Pune, and from the load balancer the request has to go to the web server, right? That is the intranet, not internet. So they will lay some wires, and using that the request is sent to the web server, and same thing to the app server and database server. Okay, so intranet and internet has nothing to do with web server and app server. Are we clear, Shraddha?
Yes, but means can you just come again? Actually, I'm not getting you.
So you see, this is the network, both is a network, but this is the network which is owned by, let's say this is for Facebook. Okay, this network is laid by your Facebook guys. Okay, so this can be used only by the Facebook. Nobody else in the world can. At least, do you understand this one, this point?
Yeah.
Okay, so this is only the communication between load balancer to web server, and this network is only the communication from the web servers to the app server, and this network is only for the communication from the app server to the database server. As a user, you want to get into the network, you cannot, because this is owned by Facebook. Are you getting it? That's why we are intra to the Facebook. But this network, as a user, you wanted to get into it, you can, if you just pay 500 or 600 rupees, they will give you a connection. Now you can start using this network. So this is the internet.
Yeah, that's what I was saying. Means that is the intranet. That's why this is the web server.
No. In this case, the request will be sent to the load balancer. Okay, typically the request goes to the DNS server. From the DNS server, it will get the IP address of the web server, and the request will be sent to the IP address on the internet.
Okay.
I'm confusing you?
Yeah, I will I'm just getting you, so I will do.
So first, let's talk a difference between web server and app server. Okay, people who are already there, it is very, very interesting, guys. You can hear this. This is very, very interesting. Okay, first, Shraddha, I'll answer this question. Okay, difference between web server and app server. Okay, watch carefully. Okay, then automatically you will understand everything. Okay, difference between web server and app server. It is important for everybody, guys. Whoever is there, they can listen to this. Okay, difference between web server and app server. Okay. To understand the difference, you have to understand the difference between a static page and a dynamic page. Okay?
Dynamic page.
Shraddha, watch carefully. Okay? I have my college website. Okay? I have my college website or my university website. Okay? It's a simple website. Whether Kumar visits it, Shraddha visits it, okay? Sorry, Shraddha visits it, or Phil visits it, or our Krishna visits it, or whoever visits it, or Melly visits it, the same page will be displayed. Okay? Every single page, it's the same page. There is no change in the page. Forget about university website. I'll take my own company website. Okay? Isha website. Okay? So, this is my website. Whoever visits it in the world, it's the same page. It's the same page that will be displayed here. Okay? Whoever clicks on this link, same page will be displayed. Same page will be displayed. Whoever clicks on this, the same page will be displayed. Whether it's Shraddha or Kumar or Phil or Melly or Krishna or anybody in the world, whoever clicks it, it's the same page. So this is the static page. This is the static page. Is it clear? Shraddha, are we clear so far?
Yeah.
Okay. Now dynamic pages. Okay. So let me go to my Facebook page. Okay. Let me go to my Facebook. Okay. I've already logged in, so that's why you are able to see this. Okay. Once I logged in, am I able to see my wall or your wall? I'm able to see my wall. But
Only mine.
Yeah. If you log in, would you see the same page or different page?
Different one.
Different page. So depending on the user, the page is different. For both of them, it's a wall page only. Okay. So, but for you, what is the content that is displayed for you is different from the content that is displayed from me. Do you agree? Do you agree?
Yeah.
Okay. This is what we call it as dynamic pages. The best example is Facebook. Okay. So far it is clear. Now, for the Isha website, okay, all you need is a web server. You don't need an app server. Whenever there is a logic, whenever there is a business logic, whenever it has to make some decisions, whenever there is some smartness that should be there, then only the application server comes into picture. Otherwise, web server is good enough. Web server is good enough. So, if you go to my Isha page, okay, what they will do, they will design this page. Okay, they will design this page and put that page on the web server. Only this page? No, they will design this page. That page also they put on the web server. So let me go to the paint. Okay, so let's say this is my web server. Now, okay, let's go to this. Let's say this web server is for my Isha. Okay, Isha website. My web server is for my Isha website. They will design the home page, and the home page will be put into this. Okay, they will design about page. That about page is put into this. So they will design the services online training page. They will design that. So every single page that you see over here will be put into the web server. Now from the client, okay, from the client. Now as soon as I click on, let's say, interview questions, okay, now a request is sent to the web server. Okay, a request is sent to the web server. Now let's say that is my interview pages. Web server is smart enough to understand that you are requesting for the interview questions page. It will pick up that interview questions page and it will send the response back to you. There is no logic here. There is no smartness. There is nothing over there. Okay, it will just pick up the page, send it to you, and you will be able to see the interview questions page. You will be able to see the interview questions page. Okay, so this is what is the web server when there is no logic. But imagine, so far it is clear, Shraddha?
Yeah. Now it's clear.
Okay.
Hey, Kumar?
Yeah.
I got a question. Earlier, I thought that you said when you get to the login page, it makes the web server makes a request to the app server.
Yes.
Is that is true?
That's true, because it has to make the logic, right? It has to. Okay. In the realistic
Well,
world,
before you enter your username or password, just when it renders the login page.
the launch page.
Does it?
Okay. So you're saying that before it renders the launch page, does it really have to go to the app server? That's what you're telling me, right?
That's what I'm asking. I
Yeah.
don't know.
If the launch page is changing from time to time, okay, today it is one, tomorrow maybe something else, it happens, then it has to go to the, okay, think about this, Phil. Whenever do you think there is a logic that is involved, okay, then it has to go to the app server.
I understand. Okay, so logic means it goes to the app server. If there's no logic, if it's all static images, then it just stays. It doesn't need to go to the app server. It just goes to the web.
Web server. But these days you understand that you have web app servers, right? You don't separate web server, app server.
Yeah.
Okay? Yeah. But this is just theory. But in the real world, you have web app server, not web server, app server separately. Both of them work together. And the line is
Yes.
also decreasing. By definition, this is what it is. But these days, the web servers are becoming smart enough and they can do certain stuff. Okay? So
Right, I understand.
it's logical as well. Okay? But
A little bit. There's a little bit of overlap nowadays with.
Yes.
With,
Yes. Okay, but I don't want to talk about all that because students get confused. Okay, however they get into the projects, they will start realizing all that. Okay, but there is an overlap, as you said, there is an overlap. But by definition, I'm just going with this. Okay, now Shraddha, we have the app server. Okay, whenever there is a logic, okay, it has the business logic. Now let's see. Now the request comes to the web server. It will do whatever it will do for the wall. Okay, if it's a wall, okay, it will do whatever it has to do. Oh my God. Whenever I log out, I don't even remember what the passwords are. Okay, so now I can't even log in to show you. Okay, let me try that. Okay. Okay, fine. Not an issue. I'll try to figure out my Facebook. I got locked, I will. Okay, so whenever it has some decision, whenever the web server says, oh, I can't work on this page completely, I need the help of app server, this is when it will send the request to the app server. App server typically contains the code. Shraddha, are you understand? Code means intelligence. Do you agree with that?
Yeah.
Shraddha, it has some logic, it has some intelligence. So based on that logic and the intelligence, it will do whatever it has and then sends that particular stuff or the data or whatever is required to the web server, and web server will create that page, the layouts, the colors and all that, and then finally send it to the client. Are we okay with this, Shraddha?
Yes, we are okay. So in that case, means when web server is different and app server is different, then when logical requests are there, then it goes to app server.
Yeah.
But right now we are using web app server.
Yeah.
So if there are so many web app servers, so then how my request will go to different buckets?
That's what we discussed, right? Load balancer is what we have discussed, right? No?
Yeah. Load balancer. Yeah, fine. Now I got it.
Yeah. Now there is one more thing I'll tell you, Shraddha. Okay. So just watch carefully. Okay. This is when your 100% it will be. Phil, for you also 100% it will be clear. Okay. So there is a very, very interesting document that I came out with. I don't know where I have stored that document. I'm searching for that. Just give me a moment. Okay. Can you see a document which says web server, app server talk or something like that? Look for a document called web server, app server talk. Okay. So
just to press W, play W.
No items. It says there is a wonderful document that I've created. Okay. One of the students couldn't understand, so I came out with this. Just give me a moment. Okay. I'll search for that document. It should be there somewhere. Okay. This is the one. Okay. So now Shraddha and Phil, watch this carefully. Okay. Watch this carefully. This is a hypothetical situation wherein our app server is talking to web server and web server is talking to app server. Both of you ready, and everybody there in the call, are you ready? Can we go through this document once? Are you ready?
Yes.
Everybody? Phil? Okay. So I hope, Phil, this will absolutely clear your doubts about the difference between app server and web server. Okay. So you see, app server is saying, hey web server, and web server is saying, yo, what's up? Okay. So this is the guy who says yo. Okay. So hey, not much. Okay. What can I do for you? Web server is saying, what can I do for you? What can I do for you? Now app server is saying, watch carefully. This is what I want you to listen to it very carefully. Okay. Well, I know that you're really great at serving up the static files. I've gave you enough background as to what is the static pages or the static files. Okay, what is app server telling to the web server? What is it saying? Well, okay, let's concentrate on this part here. Okay, well, I know that you're really great at serving up the static files and all, but you're going to get some crazy requests for JSP and servlets. JSP and servlets is the programs, is the intelligence. Okay, it is requesting for the programs. It is requesting for some dynamic content. Okay, JSPs and servlets are what? Let's assume this is the Java application. Okay, so it is requesting for JSPs and servlets, which means that it is requesting for the dynamic contents. Okay, that you won't be able to find them in your file system. That you will not be able to find them. Let me go to that. Yeah, this is where it is, right? Yeah, that you will not be able to find them in the file system. You have some static files in your file system, which is all good, and you are very good at serving them. I know it, but you get some requests for JSPs and servlets, which are the requests for dynamic content. Requests for the dynamic content. So, you don't have that. Those programs are there on my file system. Those programs are there on my file system, or those programs, the Java code is there with me. Okay. Now web server is saying, okay, really, what am I going to do? I won't be able to find any of these JSPs and servlets on my file system, and I will end up sending a bunch of 404 errors back to the client, and client will be not happy. I should have not happy, but let's say it's an American word, pissed. Okay, so the client will be pissed. Are you okay with that so far, guys? Are you okay with that? So now web server is so concerned. If there is a static files, I'll send the response back. If there is a dynamic files like request for JSPs and servlets, I end up doing what? 404 errors back to the client. 404 errors back to the client, and client will not be obviously happy. Okay. So far it is clear, guys. So far it is clear. Can I proceed further?
Yes, that's a great document. I like that.
Okay, so this is now you understand the line as well, Phil. What is that line and all that. Okay, internally what is happening. Thank you, Phil. Thank you. Okay, so now app server is saying, hey, calm down. Hey, calm down. Don't worry about it. Here is what you can do. Okay, just take those requests and send them to me, because I handle the request and generate some HTML and give that HTML back to you, and you can send the HTML back to the client. Okay, so whatever the request that you can handle, you handle it. The others you send it to me. I will take care of those requests because I have the capability to take care of those requests for the JSPs and servlets. And one more thing, beautiful thing, I'll generate the HTML for that. Okay, and web servers understands HTML language. Okay, so generates the HTML, and I will send them back to you, and blindly you send them back to client. Don't even worry about it. So your job is done. So calm down. Now let's see what web server is saying. Okay, cool. You do that work for me, and the client think that it's me. It's me who is handling the request. The client who is sending the request don't even know that it's an app server who is doing the job for him. The client would think that the web server is doing all that for me. Okay, I like this arrangement already. How do I know what files to send to you though? Okay, how do I know what files to send to you though? Okay, now let's see what app server has to say. Okay, now let's see what app server has to say. Okay, whoever wants this document, please let me know, guys. I'll send this document to you. Okay.
Yes, can you send it to me? I definitely would like it. It's very good.
Sure, I'll definitely.
Yeah, send it to me as well.
Okay, sure. Okay, wonderful, wonderful. Okay, so I'll send it to all of them. There's a lot of people saying, okay, I'll send it to all of them. Now web server is so concerned. He's happy with the arrangement, but web server is concerned like, how do I know which request is something that I can serve, and how do I know which request that I have to send you? Okay, so now again, Melly, I'll do that. App server is saying, don't worry, I'll make a thorough list and write it down all in the special XML file, just that you can read the file every once in a while and keep you updated on which files you have to send it back to me. So what is the app server is doing? It is creating the file. Okay, it is creating the file. Where is the lines here? It is creating the file with all the requests that it can handle. Okay, and that file is in what? XML. Why XML? Because XML is the universal understood language. It can be understood by anything. It can be understood by Java. It could be understood by .NET. It could be understood by Python. It could be understood by web server. It could be understood by every single technology out there. So that's the reason why. It is creating in the XML. Where is the size? Come on, size. Yeah, no. Okay, so I lost it. So this is the XML file. So this is, I'll create what all the things that I can handle. I'll put that in the XML file and I will give that XML file to you. I'll give that XML file to you so that you can keep it, and from time to time, you can look at it and update your list. Okay, so that you can update your list. Now you know what to send to me and what not send to me, because you already have the list with you. You already have the.
So it's kind of like caching it, in a sense.
It's not. I don't know the right word, but I don't think it's caching. Caching is usually happens when a certain piece of code comes here. But maybe I'm not good enough to tell that, or I'm not knowledgeable enough to tell that part. But at least I know caching means a certain piece of code, it comes over here. That's what is caching. Caching usually happens from database server to the app server to the web server, and web server to the client. Caching happens on all the levels. But whatever we are doing over here, is that a part of caching or not? I'm not sure about that. Okay?
But it sends us a file over and it updates it periodically to get new updates. And that's why the / page gets updated. Right. Because it's hitting the app server on those requests. Okay.
Yes. And one more thing is why it needs to be updated, because your newer versions of code coming in, right? So it's very important to update it. Okay. Next thing, web server. Great. But when do I get a request for an item on that list? How will I know where to send? Okay. In the app server itself, where to send. That's what is the web server is saying. For this, let's see what app server is saying. Hey, don't worry, I got it all covered. The XML file also contains the list of which IP addresses, port combinations to send the request to. It's all right. There is that XML, and if you have any problems understanding how to use it, there is a DLL. DLL is library files. Okay, that explains everything to you as well. Read it every time you start up. So whenever you start the web server, you will have to read the DLL file so that you understand what's there on the XML. Okay, so cool. I think this is going to be a great relationship. Okay, so are we clear, guys? Are we clear? Okay.
So it maps each IP address to each update on the XML file for each IP?
Right. I mean, this is what we are talking about, the vertical scale. Not vertical, horizontal scale. Okay. So sometimes what happens is it's a piece of code. I don't want to get really deep. I should have deleted this file, because as we discuss this, right, it go really deep. Okay, so this is my knowledge. I'm not 100% sure about it, because most of the knowledge that I give, it's not something which I've read, but it's something which I worked on. But this is something which I haven't worked. I'm not quite sure, what it is. But usually what happens is in the app server, you could have one more app server wherein some piece of code is there in the app server and the other piece of code is there in the other app server. It's not a mirror. When you have an app server vertically, it's a mirror of it. Okay, but there is one app server. It's some piece of code is over here and some piece of code is over here. Okay, that usually happens. Did you see that kind of things, Phil, in your projects?
Yeah, I think so. I think what you're just talking about, like different copies or
no, not
of the code. Or?
I'm not talking about the copies. A piece of code is over here, certain functions, certain libraries, certain jar files and all that. The other functionality is over here.
Oh, yeah. The modularized and different files.
Okay.
Depending on the functionality.
That's what we are talking about here. That's what we are talking about.
Yes, I got it.
Okay, and these days the architectures have become, the others, don't get overwhelmed. Whatever I've told you in the class, it's good enough for you, but we are really going deep. Okay, so
yeah, no, okay. I appreciate it.
Okay, so there is a term called interoperability. Have you heard about this term?
Yes.
Okay, which means that these days, okay, you have two app servers. certain functionality is there on the app server 1 and certain functionality is there on the app server 2. Okay, AS2, let me call this as AS2. Okay, now this one is built on, let's say, C and C++. Okay, and this is built on, let's say, this app server is built on Java. This is quite possible. Okay, this is quite possible. Okay, so this is what we call it as interoperability. You still be able to communicate with each other. These two will communicate with each other using the technology called web services. Okay, so this is what web services will allow the interoperability. Okay, so this is completely developed in Java. This is completely developed in C. So let's say there is a method which is created on this one. There's a method which is created on this one. There is a class that is created on this and the method wants to call that class. But this is in C, C++, and this is in Java. So how is it possible? By using the technology called web services. And this is one technology, this is other technology. They are talking to each other. This is what we call it as interoperability.
Would those be considered an API?
Application interfaces. When we talk about web services, there is no interfaces. It's a web services. And we talk about physical files. APIs is when we talk about the same technology, you expose the interfaces. If both of them are Java, then you expose the interface so that they can connect to each other, and using the interfaces, you can consume the code. Okay, but when you're talking about web services, there is no interfaces. There is WSDL files. Okay, WSDL files is just like your interfaces, but just that this is web services. I don't know. Okay. I'm confusing you, or I'm going really deep.
But yeah, this is too deep. So,
so I don't know how to get there because people think that it's way too complicated, and here we are learning the performance testing, right? So that's the reason why I limit this knowledge. So
I get it. Thank you.
Yeah. So when two technologies has to talk to each other, it is possible using the web services, and this technology needs to know what all is there on here. That is there. This server needs to know what all is available over here, or in other words, the menu. Okay, the menu card. It needs to know the menu card. It's not through interfaces. It is through the WSDL file, so that it can consume the code. Okay. Anyways, so let's not get there. I hope now you got a ballpark idea as to what is web server and app server. I'll send this document to you. So have a good weekend, guys. And as I've told you, please come out with the assignment. I'm expecting that assignment and send it across to me. Whoever is serious about getting the jobs. Okay. Thank you, guys. Thank you. And is there any more questions that I can take? Is there any more questions that I can take? Okay. Today I'll send 3 documents. One is the recorded videos, one is the running notes, and one is the web server app server talk. Okay.
And assignment?
And the assignment I've given you. So okay, you want me to put it in the form of an email? I'll do that. Okay. So let me write down all the things. Okay. So anybody who wants to call me, they can call me. Okay. Chaudhary, if you're already there, I'm so sorry you missed out on the first part, but it got recorded. I'll give you that recorded video. Okay. Chaudhary, are you there? You're unmuting yourself. Yeah. You're muting, unmuting.
Yes, I'm here. Thanks.
Yeah. So were you able to catch up, Chaudhary, halfway through?
Yeah, from after, yes, pretty much. I catch it up, and I'm going to go review the video, then I should be fine.
Should be fine, right? Okay. Wonderful. Yes. So
thank you.
From tomorrow, from the next class anniversary, please try to join 5 minutes before. And if there are any issues, ping me immediately so that I can take those questions. Okay. Sure. What happens is if once the class starts and you saw the crowd, right? I can't keep all the people waiting, That's a problem.
No, definitely, I understand.
You understood that, right? Yeah. Just to maintain the decorum of the class, I was not checking the WhatsApp messages at all, actually, once the class.
No, definitely, I understand. No problem.
Yeah. Thank you so much.
Bye-bye.
Bye-bye. Take care.